Every time you open your feed, someone claims they built an application over the weekend. We are in the middle of an AI gold rush, where non-engineers are deploying apps and spinning up companies at an accelerating, frantic speed. The antidote to this anxiety is a concept called vibe coding. Vibe coding is the practice of using natural language intuition to direct AI models to write software, rather than typing out the raw code manually. Traditional programming is like sight-reading complex classical sheet music. You have to memorize strict rules of syntax, formatting, and mathematical logic before you can produce a single functioning script. It forms a massive barrier to entry. Generative AI allows you to play by ear. You simply explain your natural logical rhythm to the machine, and it translates that intuition into functional, executable code. But relying exclusively on playing by ear has a serious downside. Without an underlying structure, you end up generating bloated, unreadable code. You might build a neat one-hit wonder script, but the moment you try to update or scale it, the entire system breaks. To survive this cycle, you have to adopt the slow AI methodology. This requires stepping out of the frantic rat race and treating your workflow with deliberate, highly structured care. Before you instruct an AI to write a single line of application logic, you have to adopt the habits of a senior systems developer. You need to build a stable environment first. Intentionally slowing down to structure your approach is the specific difference between a disposable, fragile script and a scalable software ecosystem. That structure starts with strict operational protocols. Sustainable coding requires you to establish clear, repetitive rules for how data moves and how errors are tracked. This chart illustrates a biological passport, an electronic record that tracks an athlete's blood values over time to establish a normal baseline. When a sudden statistical spike interrupts that baseline, investigators immediately know where to look for an anomaly. Checking your terminal logs works the exact same way. You must maintain a clean terminal history, which is a text-based log of every command and error your computer processes. When a bug occurs, you quickly isolate the anomaly in the log, feed that specific error back to the AI, and flatten it out without tearing apart your entire system. To protect this historical data, you use version control systems like GitHub. GitHub is a cloud-based hosting service that saves historical snapshots of your code, ensuring you always have a safety net to revert to if a new update fails. By strictly logging your terminal history and maintaining version control, you turn chaotic, panic-inducing bugs into a predictable and highly manageable process. Once your environment is stable, you need to define your AI tool stack. Effective vibe coding requires a specific two-part division of labor. First, you use Claude as your primary engine. You reserve Claude exclusively for generating robust, high-level coding logic and core application features. Second, you use Gemini for a distinct, separate role, handling your command line interface tasks. The Command Line Interface, or CLI, is a text-based user interface used to run local programs and configure your machine's environment. Keeping creative logic generation completely separate from environment configuration serves a very specific purpose. It prevents your AI's context window, the maximum amount of text it can remember at one time, from becoming bloated, confused, and prone to making mistakes. With your tools in place, we turn to the physical architecture of the code itself. You must break giant monolithic scripts down into small, modular components. This diagram shows Mordecai's three-part standard for organizing those modules. Block 1 is access. Its only job is to retrieve raw data from an outside source. It passes those raw particles to Block 2, transfer, which reformats the information. Then, clean data flows into Block 3, the engine. Here, your core processing logic lives, executes the main task, and produces a final output. Isolating these three functions provides a massive structural advantage. An error in your data access phase will simply throw a clean error code, guaranteeing it won't accidentally corrupt your core engine logic. Building modularly results in a permanent library of reusable software components that stays with you long after the initial app is finished. Future app development then becomes a highly efficient process of snapping together these pre-built modular blocks, rather than starting completely from scratch every single time. This approach removes the technical gatekeeping that once kept non-programmers from building complex software. It allows anyone with a logical vision to build highly complex, professional-grade tools. Success in the AI era requires acting as an architect. If you slow down, enforce your protocols, and build modularly, you can let the AI do all the heavy lifting. This video was produced by Project Hamburg Research, Inc., a nonprofit dedicated to analyzing the impact of AI across education, law, healthcare, and finance. To learn more about our mission, visit projecthamburg.org.